Ozone in the troposphere. The other 10% of the ozone in the Earth's atmosphere is found in the troposphere, which is the portion of the atmosphere from the Earth's surface to about 12 kilometers or 7 miles up. In the troposphere, ozone is not wanted. Ozone is even more scarce in the troposphere than in the stratosphere. But even in small doses, this molecule can do a lot of damage. Tropospheric ozone, or bad ozone, is an air pollutant that damages human health, vegetation, and many common materials. And just to confuse things even further, ozone in the troposphere is one of the greenhouse gases. The naturally occurring greenhouse gases, including ozone, are what make Earth habitable for life as we know it. But scientists are very concerned about the warming effects of increased greenhouse gases caused by human activity. So, in the troposphere, accelerated ozone levels deal us a double whammy as a key ingredient in smog and as a powerful greenhouse gas. Measuring stratospheric ozone. To study how much ozone exists in the stratosphere, scientists set up a series of ground-based instruments that determine the amount of ozone over specific spots on the Earth. This was done by measuring the amount of UV radiation that was reaching the surface at a particular location. The more radiation received at the surface, the lesser the amount of ozone gas present in the ozone layer above that location. The lesser the amount of radiation at the surface, the greater the amount of ozone gas. This research revealed that ozone levels naturally change with the seasons and with global circulation of the atmosphere. Initially, these natural changes were minimal and showed no threat to Earth's surface. However, in the 1970s, it was noticed that ozone levels were beginning to decrease. This depletion was not understood at first, but as time went on, researchers realized that the ozone layer was indeed becoming thinner in some regions. The depletion of the ozone layer was found to be the result of human-created gases that are interrupting the natural chemistry of the ozone layer in the stratosphere. During the early part of the 20th century, scientists were experimenting with different gases that could be used for refrigeration. The first gas used for refrigeration was ammonia. However, this could be deadly to the surrounding environment if it leaked out. Chemists then synthesized a gas that could be used for refrigeration but was not deadly if it leaked. This gas was called a chlorofluorocarbon, or CFC. One popular CFC gas used in refrigerators and air conditioners was Freon. Other CFCs were also used for industrial processes, as propellants in aerosol spray cans, in foam production, and for cleaning electrical parts. Over time, CFCs began to increase in concentration in the atmosphere. When CFCs are released into the atmosphere, it takes approximately 2 years for them to rise up to the level of the stratosphere. At low atmospheric levels, CFC gas does not react with other molecules and is harmless to life. However, as it rises up into the stratosphere, it undergoes chemical changes that lead to ozone destruction. A CFC molecule is composed from atoms of fluorine, chlorine, and carbon. When a CFC molecule enters the stratosphere, it is exposed to high-level UV radiation. Like a molecule of ozone, high-energy radiation breaks the CFC apart. When this occurs, chlorine atoms are freed and begin to join with the oxygen atoms in the ozone layer. This creates chloride compounds that remove individual oxygen atoms from the stratosphere, causing a decrease in oxygen molecules that normally combine to create the protective ozone gas. Therefore, CFCs are primarily responsible for depleting the ozone layer. Other chemical compounds, such as bromide and halons, are also responsible for some ozone destruction.